Welcome back. So let's start discussing about Azure Cosmos DB and the different concept related to Azure Cosmos DB. So you can see series of videos coming in which explain different concept in Azure Cosmos DB because industry wide there is a lot of adoption of Cosmos DB for its advantages and different flexible option that it provides. So definitely this is a very important concept when you are trying to learn data engineering with Azure. So hope you understand and follow all these videos step by step and then so that you can understand Cosmos DB in great detail. So before proceeding, if you are new to the channel and haven't yet subscribed for this channel, please do like and subscribe for this channel, and also don't forget to press bell button for instant notifications. So let's get started. So before actually jumping to the actual details of Cosmos DB more technically, so let's understand why the Cosmos DB was introduced by Microsoft and what was the challenges Microsoft has seen as an opportunity to pitch in this into the market so that it can get advantage of it, right? So if you see here, Azure Cosmos DB is nothing but it's a distributed and also it's a global database. What that means? So when we say distributed and global, so that means whenever you are doing some transaction in region B, so that has to be reflected immediately to the region A. Example, a person is performing a transaction in region B and that immediately has to reflect into region A. So there are different, options that you can choose because it is not so easy to replicate immediately, right? When we're talking about immediately, fraction of milliseconds that we are talking about, and there is a lot of issues that might come in and a lot of challenges that might come in, as you can foresee that. So whenever there is it's the consistency, we are talking about more of consistency of the data, right, across the regions. So here if the transaction is happening at 1 a.m., so immediately within a millisecond it has to be reflected to region another region, and the user which is accessing that data, he should be able to see the transaction. But there are different pros and cons of doing that. So Cosmos DB has given different options when we are talking about this data consistency levels, so that we can see in further videos. But so that is what we are talking about, distributed and global. So distributed, nothing but we are trying to perform a distributed kind of a storage here. We are actually distributing the same data copies in different regions so that the users which are near to that particular region can access the data immediately. So you can clearly imagine, you can clearly guess that the latency will be obviously very less. So that is the, if you're having a user at a region A, you have a user at a region A, so you can have the Cosmos DB created at region A. Whenever there is a many number of users from region A trying to access, right? So they need not go to the region B to get the data. So they have their own region where they have the latest copy of the data and they can access immediately with a very less latency. So this is the whole intention of calling it as a distributed or global database. And definitely the cost and maintenance was not worth. When I say not worth, before introducing to the Cosmos DB, if you are thinking about this scenario, right? So this was not realistic because a organization cannot afford to have deploy multiple databases in different regions and physically maintain them, pay the cost, and provision them. It was not giving the business value for them, so it was not so realistic. Uh, and also the latency, right? If you are not introducing this, so definitely the latency of data access will be definitely less high basically. So that's what we want to bring, the latency of the data. So if you're talking about the current situation and we have a huge amount of data, so it's not just a volume, and it is about the velocity of data and the different kinds of data that we are getting, right? So with this volume, velocity and variety, we call it as a big data. And since the data is growing in a enormous volume, so it makes it challenging when we're talking about the latency. So that's the reason latency has become the need of the hour. And we have actually a short, there is a SQL Server which is again a product of Microsoft, but definitely this is it's like a database, right? So we are having a lot of shortcomings. Say for example, it's not a distributed and it's not a global database, and it cannot handle big data kind of data which is continuously flowing through. When you're talking about IoT and uh, IoT sensor data and some kind of streaming data, so definitely the data is continuously flowing at a high throughput, right? So in that case, this was not suitable. And if you're talking about the scalability, if you want to scale it on the fly, so it was not so easy in the SQL Server. And SQL Server also, it was not good at handling variety of data. Cosmos DB is good at handling variety of data, that we will see in the next slide. So that was also because of this shortcoming. Microsoft realized that so we need to have we have an opportunity to grab here. So that's why they introduced the Azure Document DB. But further, they renamed it to Azure Cosmos DB because of some reason that also we will see in the further slide. But as you can see, Azure Cosmos DB was generally available to public on 2017. So next, jump into next slide where we talk about Azure Cosmos DB features. So before going to features, there's a one-liner definition of the Cosmos DB given by Microsoft. That is, Azure Cosmos DB is a globally distributed multi-model database service for mission-critical application. So we need to break down these things, right? So it is a globally distributed multi-model, and it is used for mission-critical. Mission-critical, definitely you might have understood, it is for some kind of application which are very critical in terms of their operations, and we cannot have afford to have a milliseconds or seconds of a downtime. So it should be the availability and reliability should be very strong. So that's what we call it mission critical. And globally distributed, I think you are already clear, but we are also talk about multi-model database. So going to the next thing here. So that was about the definition, and coming to the actual features of Cosmos DB. So definitely it is a fully managed and globally distributed. By this time you might have understood this point, but it is actually a database as a service. So you can consider it as a database as a service or software as a service. So both is actually holds good here. And it is a serverless. Definitely it is serverless because you are not hosting a server and then you are not creating a database inside a server. So it is just fully managed. You are just creating a Cosmos DB and you don't care where the Cosmos DB is actually launched physically. Right? It is completely managed by Azure. So that's why we call it as a fully managed. And it is a schemaless, and there is an option in the Cosmos DB where you can have a JSON kind of format and graph kind of format where it is where it actually doesn't have a particular schema like a relational database. So that also we'll see in further videos. And turnkey global distribution. That means definitely we know it is a global distribution, but turnkey. What is turnkey? Is just in a click of mouse buttons you can make the data globally available. That means you can mirror the data into a different geographical locations and make available to the nearest, I mean, users who are nearest to that data. So that's about this first feature. And going to the next one where we were talking about multi-model, which we saw in the definition of the Cosmos DB. What does it mean is, so it is having a different kind of models based on the kind of a data or a format of the data. So it can have the JSON format of data, and it can also have a tabular kind of format of data, and graph format data, and also columnar models. So for all this kind of format of data, actually it's Cosmos DB supports, and we can choose to have any of these things. So that's why it is called as a multi-model. And coming to the multi-language, it supports Python, .NET, Java, Node.js, and JavaScript, and few other programming languages. So it gives the flexibility for the programmer to use any of these programming languages basically to query this or to create some kind of procedures on top of this, whatever we are, whatever the data is stored in Cosmos DB. So the next one, availability, reliability, and security. So definitely the feature of Cosmos DB. So keep in mind, availability and reliability is actually the basic or very important concept of Cosmos DB, because if you see the SLA here, Microsoft always talk about SLAs in after 99 point, after point we call it as a 5 nines. So that if it is 5 nines, that means you can imagine the uh, promise that Microsoft is giving with respect to the SLA. So it is a huge promise by Microsoft with this SLA, and the latency is also less than 10 milliseconds, which is actually great. And there is an unlimited scale. You can scale if the latency what the Cosmos DB is giving you is not sufficient. So then you can basically increase your throughput. Right? You can have the throughput increased. Definitely there will be a cost, but you can increase the throughput of that Cosmos DB. And if you want to have more storage, you can also scale the storage based on according to your need. So with that, it gives the flexibility of increasing, upscaling, or downscaling the storage and throughput both. So you can have the cost advantage. So based on this, actually tuning this basically, right? And next is a consistency level, as we were talking, right? So when the data is being a transaction is being made at a region A, so it has to immediately reflect in the another region. So how fast it should reflect, and so there is a consistency. What kind of consistency the data should have when it is replicating the data to other region, right? So that also we can decide. So that control is also given to the user. So this can be chosen based on certain use cases or certain requirements, or what kind of applications you are actually having to use this Cosmos DB. So based on a couple of factors, we decide these things. So there will be separate video talking about all these consistency levels. But as of now, so just understand there are a different consistency level which Cosmos is giving to the user, so he can choose that. basically, if you see here, there are a lot of promises definitely Cosmos Azure is giving with respect to Cosmos DB, and there are different flexibility in terms of scale, consistency levels, and also the programming language and also the data. So basically here, Azure is trying to give flexibility to the user to choose many things, and also it is giving a great promise of this SLA. And definitely, why not choose Cosmos DB for a mission critical applications when we have so many options and great SLA? So that is the whole advantage of using Cosmos DB, but definitely the cost of the Cosmos DB is very huge when compared to like a SQL Server, because of this kind of SLAs, and it is a global distribution and fully managed. So definitely we need to pay extra bucks to Microsoft to have this advanced DB, which is called as a Cosmos DB. So hope this was useful. Thanks for watching.